This is Shishir. This session is designed more of a question and answer session. Adis is going to walk us through how to integrate the BCM sensor, and I will fill in as we go through. Just to give you a quick overview, Balluff has recently introduced a Balluff condition monitoring sensor. Thanks, Adis, for popping up this slide. As you can see, this sensor is a tiny little form factor, but offers a lot more functionality. It offers vibration, velocity, and acceleration, and lots of statistical analysis regarding vibration with the same sensor in all three axes. So you don't have to worry about how to mount this sensor. Secondly, it has its own self-awareness diagnostics data and a lot more capabilities that are built into this, and we will walk through some of this functionality. This is a post session to a couple of months ago. We had a session on applications of BCM. So without further ado, I want to introduce Adis here. And Adis, can you first walk us through how your setup looks like for today's demonstration? By the way, I've just looked at the poll, and it seems like there is a lot of, about 70% of our listeners today are researching into their first project for condition monitoring. So,
so good morning, Shishir, and good morning, everyone. Thank you for joining us. So right now, I wanted to show you what, what does my, network look like. So as you can see here on the bottom of my page, we have the Balluff condition monitoring sensor that is connected to the IOLink master, or the gateway between the IOLink, the device network and the PLC control network. In today's case, we're using Rockwell PLC, so we're going to be using an Ethernet IP IOLink master. So as you can see here, my master is connected to a network switch that I have the PLC connected to, as well as my PC, so I can show you additional features. And then, awesome. And then here, this is the live camera feed of the physical hardware. So as you can see here on the left-hand side, that's the IOLink master. And then on the right-hand side, you can see the Balluff condition monitoring sensor that's mounted on a NEMA 23 stepper motor that has a unbalanced load. So you can see the vibration change over time as I enable the motor and spin it.
That's awesome, Adis. That looks a great thing. Now, this sensor utilizes IOLink for richer communication with that sensor to collect all these types of data. So can you briefly go over how the IOLink communication looks like before we go deeper?
Absolutely. So we chose an IOLink communications protocol for the sensor because it gives us a couple different advantages. One is that it's open communications protocol, so it doesn't belong to anyone. And then the second reason why we chose it is because the data types that it gives us, or the access to data from the sensor. So there's three different message types that are available over IOLink. One is called process data. So in today's case, the Balluff condition monitoring sensor basically outputs, vibration, contact temperature, humidity, pressure, and so on. And that would be considered process data. It's cyclical information that's fed back to the PLC. And then in addition to that process data, we have acyclical information, which is basically event-driven, and it's considered service data. So as part of the service data, you have parameters. So your PLC has direct access to the parameters of a device, which means your PLC can dynamically change the configuration of a smart device that's connected to it. And then in addition to that parameter data, we have diagnostic information. So this is a device-specific diagnostic information, and it varies from device to device and vendor to vendor.
Great. Thanks, Adis. So since this is a small, tiny sensor with all this data coming in, flowing in and out bidirectionally with the sensor, what are the different ways to configure this device? You mentioned something about PLCs, but is there can you go in details about that a little?
Yeah, absolutely. So as I mentioned, your controller, whether it's a PLC or PC, has direct access to those parameters. So in case of a Rockwell PLC, you would have to use explicit message instructions so you can read and write that parameter data to the sensor. Now, Balluff IOLink Masters offer what I call an easy button, which is basically a web server functionality where you can go in and you can virtually you can virtually see what is what is connected to your IOLink master. You can see the status of the IOLink master, and then you can also dive into a specific device that's connected to it. Now that gives you basically a focus point on that device, and then it gives you some basic information such as like IOLink identification data. It gives you process data and parameter data as well.
Great. So Adis, if we were to configure this through a PLC using explicit messaging, it would be more of a binary and hex communication.
Absolutely.
Which I can see here some of that process data.
Yes.
But and the easy button approach, which is through this web server, is it the similar way or is it a human readable form?
So what makes it easy is a file called IOD file, which is IOLink device description file that basically accompanies the smart device, and it can be loaded into the IOLink master. So the IOLink master can basically translate that raw data or that raw hex data into human readable format that's device specific. So it basically takes, for example, here you can see the 20 bytes of process data. It takes that process data and inputs it in a human readable format or device specific format. So now we can see vibration velocity, RMS values, for example, instead of the raw hex data. And then the same thing goes with parameters. Instead of looking up or referencing the user manual and looking at specific, index number and a sub-index number and then trying to figure out what is the hex value, we can simply scroll down the screen. And now we have access to parameter data and with the drop-down menu. So you can easily see what parameters are available, how your device is configured, and then change it if needed.
And this functionality is freely available standard with our IOLink masters, correct, Adis?
Absolutely. So this is not an industry standard. This is a Balluff standard, and we include it on all of our Ethernet-based IOLink masters.
Awesome. Great. So let's jump into this device. So if you go up to the process data, I noticed we were monitoring some of the RMS values up here. Now, this is pretty set. Can you explain how this information is divided?
Yeah, absolutely. So the sensor outputs 20 bytes of data, and the 20 bytes of data is broken into what I call 5 buckets of 4 bytes each. Okay. So as you can see, the first 4 buckets basically represent the real value, in this case, vibration velocity, RMS. And then the 5th bucket represents the status bits or the status of the set points that you assign around variables.
Got it. So I see it's currently only providing information about the RMS values of velocity. What other values can you obtain?
Yes. Now, because we have huge amount of data coming out or available from the sensor, but we are limited to those 20 bytes, you as a user have ability to basically customize the content of those buckets. Now, Balluff predefined 5 profiles. So as you can see here, we have vibration velocity RMS, vibration velocity peak to peak, vibration acceleration RMS, vibration acceleration peak to peak, and then environmental data that includes pressure and humidity. But if that's not what you want for your specific application, you can choose a custom data profile, as you can see here. So if we click on that and we configure the device in that custom data profile, now we can use this parameter below it to assign variables to those buckets.
Okay, so we can collect the information that we need, because I know this sensor also offers some statistical measurements about the vibration, so we can
Absolutely.
configure those here.
So let me show you what's available to you. So here's a
Awesome.
first drop-down menu, and now don't be overwhelmed, Shishir, but there's a lot of different options here to choose from, including the statistical information that you have mentioned.
So given your setup with that stepper motor and this BCM sensor mounted on top, I would say that's mounted on the Y-axis. So can we select maybe Y-axis or peak to peak? Let's take peak to peak value.
Sure, absolutely. So we have assigned bucket number 1. We have 3 more to go, Shishir.
All right. Secondly, can we get the total magnitude on all 3 dimensions?
Yes. So do you want RMS or peak to peak?
Let's do RMS magnitude. I mean, it doesn't make sense to me right now, but let's try it out.
Okay.
How about, does this have like a humidity as well?
Yes. So this version of the condition monitoring sensor includes relative humidity, so we can select that.
Perfect. And the 4th one, this is a contact temperature, not the ambient temperature, right?
Yep. So we can leave that as is.
Okay.
And now we're gonna write the parameters to it, and now our sensor is configured in a custom data profile, and we were able to customize the content of the process data that's going to the PLC.
So Adis, you also mentioned something about setting alarms or setting some set points. Can we do some set points as well? Or is that
absolutely. So if you continue to scroll down, you can see the parameters that are available to you. But for the today's purpose, we can choose the
contact temperature
alarm. So right now we can read the current configuration. So right now our low alarm is set at 15 degrees Celsius, and then our high alarm is set at 30 degrees Celsius. So now we can adjust that based on the current temperature of the motor, which is 27.5 degrees.
Okay. So should we leave it at 30?
We'll leave it because of the time. We'll bring it closer to that set point. So we'll leave it at 28 degrees Celsius. We're going to now overwrite the current settings, and now our alarm is set for 28 degrees Celsius.
Awesome. So just to catch up here, all this configuration can also be done through PLC utilizing parameters and the appropriate arguments for those parameters through the hex codes.
Yeah, absolutely.
If you're expert in that. Otherwise, this is another easy way to configure that sensor. So now we configured this sensor. Can we take a look at the process data quickly up here before we switch?
Absolutely. So if we scroll up, we're going to look at a custom data profile. So as you can see here, we're looking at a custom process data profile, and now here's our relevant information that we have configured.
So just because we chose custom data profile, that headings are changed to slot 1, slot 2, slot 3, because it could be any data that is put in.
Absolutely, yes. Mm-hmm.
All right. So switching. So I'm guessing that the slot number 4 is where our contact temperature is, and is your motor running right now?
It is not. It is not. But why don't we go into the PLC? Why don't we go into the meat and potatoes, and then we'll show you what that looks like.
Sounds good. So let's switch to PLC. Show us how to integrate this.
Perfect. So here's my Studio 5000 project. I have I'm using a Compact Logix PLC along with the Ethernet IP IOLink master and a condition monitoring sensor. Now, because of the time constraints, what we did some pre-configuration in my project. So basically, I've added add-on instruction for the IOLink master, and I parsed out the information coming from that master into each individual port data.
Okay. So just for our listeners, how to integrate the IOLink master into your PLC code. Those how-to videos are available through our technical YouTube channel. Mm-hmm. And Chris, would you mind posting the link to that YouTube channel in the chat? as well as a specific link for integrating the Ethernet IP IOLink master that's shown here by Adis. So, okay, Adis.
Okay,
so take it forward.
As you can see here, I'm live with the PLC. So the first thing we want to do is download the AOI from Balluff's website. So we have an extensive AOI portfolio that you can choose from, and basically every Ethernet IP and IOLink device that Balluff has to offer is accompanied by an AOI for ease of integration. So I've already downloaded that, and the next thing what I'm going to do, I'm simply going to go ahead. There's a little bit of lag. Oops. So right now, what I'm going to do is I'm going to basically click and drag the BCM AOI. Give me 1 second. Let me adjust the screen here.
Just a quick one. Since you're mentioning AOI, for those who may not be familiar with the Rockwell, AOI is more like a function blocks.
Absolutely. Yeah. So we're basically, we're using object-oriented programming. We have add-on instruction that basically takes the raw data from the IOLink master and puts it into, data structures that are relevant to those devices. Just like the IOD file, made it human readable. We're mimicking the same thing here in a Rockwell environment.
Awesome.
Okay. So the first thing we're going to do, we clicked and dragged the AOI. Now we're going to have to basically declare an instance of that AOI. So I'm just going to keep it simple. I'm going to call it BCM. Okay. So we're going to declare the instance of this AOI. Now the next thing what I'm going to do, I'm going to take the port data from the IOLink master, and I'm going to point it to the AOI of the condition monitoring sensor. So I'm connected to port 1 data, and then lastly, I want to create a tag for BCM map data. So I'm going to call it BCM map data. Okay. I'm going to declare that variable.
So that's the collection point for the data coming from the Balluff condition monitoring.
Into specific data structures, yes.
Got it.
And then lastly, there is a user input here at the very bottom. And basically, you have to tell the AOI which profile are you using, because we have 6 different options, as we mentioned. You, as the programmer, have to tell the AOI which profile are you using. So in our case, we're using a custom data profile, which is number 8, and that's referenced in the user manual. So all I have to do here is basically put a number 8 in. Okay, so now I'm basically telling the AOI I'm using a custom data profile. And now we're going to basically download the changes, and that's it.
And those profiles can be automatically changed based on your program needs.
So yes. So as I mentioned, your PLC can dynamically change the configuration of the sensor. So you can either do it event-based or time-based. You can change the profiles and collect the relevant data.
Okay. So before you continue on, we set an alarm on that contact temperature high value. Can we show some kind of an output here?
Yes. So the first thing what I'm going to do is basically just show you what the information looks like. So if we look at the input data, from the sensor here, we can look at the profile. This gives us the real values that we have customized, and then of course we have the status bits here, right? Okay, available in a specific data structure. So the next thing I'm going to do is I'm going to basically very quickly add a contact and an output. And there is a little bit of lag here. Okay. So for my contact, I'm going to call BCM map data.I for input data. And then I'm going to look at my status bits, and then I'm going to scroll down for the contact temperature, upper alarm. So we're looking at that upper alarm that's set to 28 degrees Celsius. Okay. So we're using that contact, and then we're going to set an output. We're going to call it LED. Okay. For the sake of this. So it's just going to be a Boolean. Okay. We're going to download the changes. And now we basically created a condition within our machine controller. Okay. So now we're using that in our logic. Okay.
So while you're starting up your stepper motor there, just to recap, we first added a IOLink master, configured that IOLink master. Then we selected an add-on instruction for BCM, configured the port number for that data, selected the data structure to put that parsed data in, and now we are putting alarms or conditions, whatever we want to monitor, to set some outputs.
Yes.
Awesome.
Absolutely.
See
so
your
stepper is
motor
moving. Yes, it's moving now. We're just waiting for the temperature to ramp up and set our output. And you can basically pretty much mimic the same thing. You can use any one of those status bits to condition your machine.
And is that all needed to integrate BCM into this Rockwell platform?
In essence, yes. That's all you need.
So you can set these. There it is.
There it is.
Looks like yeah, it's turned on.
So now you can shut down your machine. You can turn on the end-on light. You can basically, control your machine based on the conditions.
Great. Thank you, Adis. In the interest of time, this is where our demonstration ends. We showed you how to quickly integrate a BCM sensor in the PLC logic. If you have any further questions, please feel free to put it in your chat box. Hey, Chris, back to you.
Thank you, guys. Thank you for that demo there. And right now, we're going to go ahead and move towards our Q&A. So we did have a couple of questions in the chat here. So Jordan is asking, do you need the newer master firmware for this sensor?
Adis, you want to take that?
Not necessarily, no. Now with the older style IOLink masters, you may not have access to the web server for functionality. However, we're still going to be able to, connect this sensor to it, and we're still going to be able to, exchange that information with the PLC. So the short answer is no, but you may lose some functionality.
Got it. But so the web server functionality has been added, I believe, from hardware 6 onwards on our IOLink master. So if you have a hardware 6 or above, this functionality is available.
Yes.
For configuring the device. Yeah.
Okay. And then Brian is asking, is there an AOP, I don't know if he means AOI, for Rockware software available?
So add-on instructions and add-on profiles are two different things. We do not have add-on profile for these devices. We only offer add-on instructions.
Okay, and then let's see. I'm trying to see if there's any other. Yeah, we do have one more question. Can the Balluff products be integrated with a CAREL, C-A-R-E-L PLC system?
As long as any PLC that offers Ethernet IP, Profinet, EtherCAT, these IOLink masters can be integrated, or CC-Link, IE, DeviceNet. Yes, so all the PLCs that support any of these 7 field buses, you could utilize the BCM with that.
Now, you may not get add-on instructions for it, but we can certainly communicate and pass information to it. And we can support you by telling you what to do with that information. Absolutely.